Hello, I am Arnav. I'm still a third-year engineering student. I'm going to talk about hacking the Android OS code. By the way, before I begin, I would like a quick show of hands for a couple of things. How many of you have developed Android apps before? You know about the process, so everybody. How many of you have ever worked with or experienced working with the OS code, the AOSP as we call it? So, yeah. And so, for these 4 or 5 people, I think at the beginning it will be a little boring. So let's start by understanding the Android OS in the beginning. The slides will go on for like 15-20 minutes. After that, we'll start some hands-on codes. So before we begin, I want to just share a few things. Like this is a diagram that I think a lot of people have seen a lot of times. So the Android architecture diagram basically, so you have the applications, the application framework, the libraries, and the Linux kernel. So basically at the bottom of this whole chart is your hardware. At the top of this chart is your user. This is how Android works. So I'd like to just give a bit of lowdown on these things like applications. When I'm talking about Android OS here, so I'm not talking about even the apps that you get on the Play Store. Just the OS itself already has quite a few apps. Like the ones you see in the launcher of a default device that you get, that's there. Other than that, also a lot of things are in the format of apps. So apps, as you can see, it's written out there. It's simple bundled into APKs, what all of you app developers have been doing. Then just level below is your system UI or the framework, all over that, whichever is handling the UI part. So this defines everything else, like how the buttons look, how the checkboxes look, how the switches look, how the navigation bar looks, how your lock screen looks. So all of this is there in the system UI, which is basically the Android OS's abstraction layer for the graphical side. Then the other part of the frameworks is basically your providers and APIs, which whenever you're developing apps, everything is abstracted to you, all your hardware. Like you want to access the sensors, so you have got some classes which are abstracting sensors to you. Or you want to say access the display layer or whatever. So all the APIs are provided to you, extracted from the bottom layer to the developer via these things. So that's also the job of the framework. Then just below the frameworks is the runtime. Runtime is, till now it was the Dalvik, which was very much like the Java virtual machine. So now Android is shifting over to a newer runtime, which, so like quote unquote Google says it's more native. So then below that are the libraries. Libraries can be of various types. Some of them are for, say, encryption libraries. You have got libraries which handle the hardware, which are called HL, hardware abstraction layer, which is a set of libraries which allow you as the developer to access the GPU, the sensors, the screen. Then finally at the bottom is the kernel, which when we say that Android is based on Linux, so it is this layer that we are talking about, the part of the OS that actually runs the hardware. So the kernel is pretty much the default Linux kernel that is available. There are some changes, like the implementation of memory and power management is different. But basically, this is very much like the mainline kernel tree that you have for any device. If you have Linux available, it will be somewhat like that. So now we are going over to how you can build Android for your phone. So how many of you know anything about it? Like you have heard that you can build Android, you can download the source on your PC and you can build that. Have any of you looked at the instructions? I think some of you have. Yeah. So just like you can build apps, you can build the OS itself. More time, more energy, more space, a lot of things have to be invested, a little more than app development. So these are the kind of requirements that you need to build. As you can see on a normal laptop can suffice for building. We are going to download, I have a copy of the source, but I will show you how it's downloaded. that we'll do. This is the link that actually describes how that process is done. It will take a lot of space. There are, in Lollipop, I think, there are 464 separate Git repositories, which all get downloaded and they get inflated in a directory structure. And shortly, I'm going to show how the directory structure looks like. Finally, when you have to build, there is a Mammoth build directory which has some 20-25 different MK files, the make files which are handling how all these parts are built. So it's like about 10 GB of source, a lot of parts selectively gets built, and finally you have a 200-300 MB image that you flash on your device. So we are going to talk about what can we modify and how, and we are talking about that at DroidCon 2014. Two of the most important tracks I felt were one about UI, UX, and another about the hardware side. So when you want to modify the Android source, I think these two are the biggest motivating factors. I mean, if you are making a new tablet or a new phone, you might want to differentiate your phone on the basis of the software. So you might like to change the user experience. That is one side of it. The other side is today we have a lot of different devices coming up. I mean, like even 1 year ago, it was only tablets and phones, and tablets are just larger phones. So now we have got smart wearables. Android is coming in cars. Android is going to come in home automation soon. So there will be a lot of devices which probably won't have a touch screen, with which you probably won't interact the way you interact with a phone or a tablet. So you would want to modify Android in a certain way that you can use it. Like for example, if you have on a watch itself, the Android Wear platform works much differently from how it works on a smartphone. But it is, after all, the core, it is the Android OS source itself. So how we can do that, and that will involve a lot of the term we hackers call is porting. Porting means to getting the Android to work on a new set of hardware. So on the slides, I would like to show you mostly about the UI side. I can show that. Then I will, for the hardware side, I will move over to show how you can actually change the code and what you can change in the code. So when we talk about the UI side, if you have run some custom ROMs, you will see a lot of the changes are like in the contacts app, in the SMS app, in the settings app. These things are something that as an app developer is not going to be something new to any of you. It's just exactly the same structure as you structurize your source for an APK. Like back in the Eclipse days, how you used to do, if you have moved to Studio, it has a different structure of code, but it's like the SRC files, Java files go there, the Res files. It's exactly like that. And the only difference is the apps that come with the OS, they mostly, directly the source you cannot build in a third-party IDE because they have some deep linking with the OS code. But the whole idea is pretty much the same. Then comes the modifying of the framework, which on the code side, I think you don't need any other knowledge other than the Java knowledge you have already for developing apps. But that is something that you have to build the whole OS every time you make changes, because these are deeply integrated with the other part of the OS. So here is somewhere you can make changes. For example, for people who have, anybody has developed any app for a specific device ever, say if you want to build an app for a Samsung phone and you want it to be included as the multi-window thing, so there is a particular API for that, right? So if you're building your own OS, you can add APIs over and above what Google provides in the default Android source, so that sometimes people want to make an ecosystem of apps for themselves. So that's one thing you can do here. Then comes the part about modifying the libraries which are going to access the hardware. And why exactly you might want to do is, one of the biggest examples is what CyanogenMod does is they have an equalizer app. So to do true equalization, you need to have deeper access to your audio chip, wherever you want amplification and all that. That's one example. If you want to improve the performance of the camera also, wherever you need to change how we are accessing the hardware. And finally, the kernel modification is something that I guess, I mean, at a third-party level, mostly people do it to add CPU governors and all that stuff. But if you're going to build a new device, this is something that's very important, because you probably will get whoever is your SoC or your CPU vendor will probably give you a Linux tree which will boot the normal Linux. So now you have to run the Android kernel on it, which has certain subtle differences from the Linux kernel. So it needs a bit of vast knowledge on the kernel side to be able to do this. So I will show some changes on the UI UX side. Very quickly I will go over them, and you can see on the UI UX side what are the things that you can do. Say for example, this is some changes for a ROM called AOKP. So this is something I think a lot of you know this exists on a lot of custom ROMs. So you can change the size of navigation bar, you can make it transparent or something like that, and can change the number of buttons that are available in the navigation bar, and you can add some extra keys like left right keys on navigation bar. From the bottom of the screen you get a Google icon, so you can add some more apps out there. This is something interesting. You can modify the total UI. So you can see this is in ICS there was a tablet mode where your status bar and your navigation bar come to the same place. So maybe you can enable that on a phone so that people have more screen estate or something like that. These are quite a lot of changes that you can do. There's also something related to themes, which is also a lot of people who make phones, they are doing. Like Sony has a very nice theming service, and obviously the custom community people, they are very interested in theming and all that. So there are a lot of this is another nice thing that has been done. This is, you can compare it to what you have on a HTC phone. You can, right from the lock screen, you can launch some apps. So, and this is, I bet, one of the best features that somebody hacking with the Android OS code has come up with, is the privacy guard. So how many of you people know what privacy guard is? Okay, so as an app developer, you know what app permissions are. I think everybody knows that. So say your app takes permission for reading contacts, because your app needs to read contacts. So if you download an app from the Play Store and it has the permission to read your contacts, and you don't want to give your contacts away to that app, what do? Any answers? You can uninstall that app. Other than that, no options. So this is a very deep-rooted thing that has been done. You can selectively turn on and off access to various permissions for apps. So that's nice, right? So for doing that, you will have to go down to the layer in the frameworks where permissions are given. So if a certain app has a permission, so that means the APIs to read contacts will be exposed to it. But when it tries to read it, if via privacy guard you said that I won't give you permission to read your contacts, so it will get a blank contacts file. So you have to work it around that way, because if you just say that no, I'm not going to show your contacts, the app will crash, because the app is expecting something return. So it will just see your contact book is empty. Right? So even with the internet also, so if you say the internet is not connected, the app will say please connect to the internet, or it will give a box like that. But if you say like internet is connected but the speed is 0 kbps. So these kind of changes that you can do with the OS. So this is something that's very important for privacy conscious users. Most of them are a lot of UI based features that, I mean, this is something a ROM called Paranoid Android did. What they made an API to change the external UI of the phone based on what app you are running. So say you are running Facebook, your navigation bar becomes blue in color. You say run Google Plus, your navigation bar becomes red in color. Okay, so this is also some of the things that can make the user interface and the experience of how seamlessly users are using the phone very different. Then what other things you can change is I can show one of the modifications I did while I was working on a project for Micromax is this. Also, I had an issue with the video. Basically, that's where the presentation ends. So I will move on to how you can actually get the source code and you can build it. So firstly, let's see. I mean, you will need to search the internet for that actually. So that's why if I'll do is I'll mirror my screen so that I can show. Yeah, so the link that I showed in that slide was how Google gives you instructions to build Android on your laptop. But as a personal suggestion, I would say if you search this thing, build Android Lollipop on Ubuntu, I search this, and one of the first results is a XDA thread. So I personally would suggest this because there are certain steps that Google misses. So this has a lot of instructions, like you need to get the OpenJDK. Another thing you can note, if you want to build something before Lollipop, you will need the Sun Java JDK, which you can get only from Oracle's site. You won't get it via any updates on Ubuntu. And the first thing I think I didn't mention, you cannot build on Windows. You will need a Mac or a Linux. And for anything above ICS, you will need it 64-bit to be able to build. Okay. So you will need a few tools in the beginning. You will need, like I said, Java. Anything below Lollipop, you will need Java 6, and the OpenJDK 6 won't do. You won't be able to build with OpenJDK 6. You will need the Sun JDK 6. Then for Lollipop and for any future version, you will need 7. You will need like Python. You will need Git, and this is a whole list of packages that you will need. Just copy that list and paste it and install all of them before you start building. Then as you can see, like this is a very comprehensive information set. Whatever kind of OS you're using, 12.04 or 13.04, they have even instructions for Mac and all that. So you will have to follow these instructions. Get the tools that you need. You will need to get it ready. And another thing is, how many of you have used ADB on Mac or Linux? Have had driver issues? Yeah, so this also, I mean, something not just related to Android OS development. If you are an app developer, you might have faced this issue. You could have solved this. UDEV rules, you have to do this also. So now we move on to the part where we are going to get the source. So like I said, the source is available. Like this is, you can note this down. You can see this android.googlesource.com. This is the website where the source code of a whole of Android, where Google publishes it. As you can see, there are a whole lot of repositories. All of them are separate Git repositories. So to download them, Google has made this nice little script called repo, R-E-P-O, repo. So you have to do this step, curl https storage googleapis.com git repo download repo, and it will come on to your bin folder. There will be this script called repo. So what this does is, this is going to help you download the whole source and inflate it in the particular order in the directories where you need it to be able to build the Android OS. Okay. How many of you have that source code right now? Show of hands. Okay, that's quite a few people. But how many of you have access to internet right now? So I would like, wherever you don't have source, I will show the place on internet where you can see the source. That's as good as that. The source code, when you download it, will be 25 GB in size because it has all the history right from Android 1.0 to this. So you will have to download the whole thing because if you want to keep in sync with the updates that Google does to the source code, so that's the best way to do it. To some people, I have distributed a tar file of the source, but the tar file you cannot update it via Git. After you get the repo script, you should make a directory, and you can make it anywhere. Sometimes a lot of people ask if that's possible or not. Yes, it's possible. Like I have it set this way. I have a folder called Android. Inside that I have got AOKP. It's one of the custom ROMs I work on, and this is the KitKat source, the Lollipop source I'm yet to download. Inside that, you run this command, which is showed on a terminal. So the command is visible. It's like repo init u, and then wherever you're getting the source from, and it will have a branch because if you want to download a Lollipop source, you have to the branch like this. So for example, instead of the AOSP source, I want to get the cyanogen mod source. So it will become, the line will become something like okay. So what exactly exists here? So let's have a look at that. So this repo will have a file like this. So it's visible now. So this has basically a list like this. The path shows where the source goes, then the name shows from where the Git repository it will come from, and then sometimes they can have a group and a revision which source it's going to download. So it's a long list. Like I said, all those 464 different Git repositories, they are mapped like this. So you do this step, your repo gets initialized, and then you have to run the command to sync it. When you do this, the whole download of that 25 GB of source, that will start. Okay. If you have a good connection, you can do J20, say 20 parallel downloads will start. If you are having any issues, like the connection is breaking a lot, repo gets hung, so you can use the force flag. If any of the repositories are not downloaded, it will skip and continue with the others. So you can check out all the other arguments that repo has. After you have downloaded it, the source should look like this. So is that visible? I mean, these tar files are not part of the source. The folders are. So I would like to give a brief description of what exactly the source means. Okay. So I'll start with some of the most important folders first. So let's say ART is the new runtime, as you know. So this has all the source code of the runtime. We will delve into it later. Dalvik is the older runtime. Then you have inside the bootable folder, this is something that is going to interest the people who probably want to get Android running on a new hardware. So it will have the bootloader. This is the source of a reference bootloader, okay. So this is not the source of the bootloader that comes on the Nexus devices. Because as a equipment manufacturer, you need your bootloader to be secure. You would not want your bootloader to be open source. You would want that if somebody wants to flash their custom firmware on it, they should unlock it via some like fastboot OEM unlock is a method you can do it. So like that. This is a source code of a reference bootloader. The bootloader, as you all know, it's going to start up all the other systems. Then another thing is the recovery. Recovery allows two things. One is obviously, as the name suggests, if something goes wrong, you can data wipe your device from the recovery. You can reflash a new build via the recovery. And finally, recovery helps you in FOTA. So you know what FOTA means, firmware over the air. Like you get upgrades to your Android. If you have a phone, you get upgrades, which are like, say, your ROM that comes with the phone by default for an OEM like Samsung, Sony, who do their own UI, it will be 700, 800 MB in size, but your updates are generally 100 MB or something like that. So it's a delta diff of it. So these updates, you want to install it on the fly. That also, what happens is the phone reboots into recovery mode. So in the recovery, your system partitions, your data partitions, they are not mounted. Your recovery updates your phone and then it again boots back into the normal mode. So for that, you have the recovery. On the recovery side, in the community, a lot of people have developed a lot of recoveries. The Android recovery is very simple. You can just flash files and it does not have a touch interface. You use the volume buttons to go up and down and the power button to reboot. There are people who have developed touchscreen recoveries. The phones that come with Cyanogen mod on board, like the Oppo N1 and this, the OnePlus, and now the U phone is going to come out. They have touchscreen based recovery that Cyanogen has developed. So this is about the recovery. Then the build folder, I will come to it at the end because this helps you build everything. This is all the build configurations. The CTS folder is something, it contains a lot of test suites that you need to pass to be able to consider Android certified, officially Android certified. So let's skip on directly to the folder called device. So inside device, as you can see, I build a lot of custom ROMs for Sony devices. So inside device, Sony, and this Yuga stands as a code name for the Xperia Z phone. Okay, so these contain configuration files for how the Android OS source code, how it will be built. So for example, inside this folder, for example, if you want to build Android for a new device, you will have to create something like device slash your vendor name slash your device name. And inside this folder, you will have some certain preset make files. So you will have your android.mk, it's a very standard template. This needs to be there under every separate module that gets built. You will have something called android board.mk. Again, this file needs to exist to tell the Android build system that this device has its own board. Okay, this tells the this android products.mk redirects to the make file where you are going to define all your configurations. And then the board config file. So in Android, when we talk about the word board generally means anything that relates to the kernel. When you talk about the device, you're talking about the Android part of it. Okay, so whatever changes you are doing on the Android side, the board generally. So here, how many of you have ever experienced working on the Linux kernel or build the Linux kernel or seen the source? Show of hands again. So, okay, so not a lot of you. So this certain flags like this are going to set which configuration your kernel will be built in. I'll go to the kernel side again. So your device will have certain parameters like the size of the boot, the size of the recovery, the size of the system, and the user data. These have to be defined here, like you can see. This is going to define how the Android side is going to be built. So like we have defined the height and width of the system. We are going to define the basic makefile that is going to be taken. So here, taking a full base telephony.mk, there are a lot of product files like this in the default build folder. So this is a phone that has got GSM on it. So I'm going to inherit the full base telephony.mk. So this is going to have the basic needs for a device which has GSM on it, phone or tablet kind of device, for example. Then I'm going to inherit whatever is specific to my device. Okay, and then I set the name, the device. So this, for example, you have written the product model. This is what comes up in the about phone screen. So what device you're building it for. Then there after that, there is the external folder is for a lot of binaries that are present on your phone, which are not part of the Android project per se. Like you can see here, there are binaries for, say, there is for Apache, there is for Bluetooth. So these are all sources that are part of the open source community. A lot of them are from the GNU project. So whatever needs you need for, like supporting web servers, supporting encryption, supporting your hardware, whatever different sources that will be needed, they are mostly here. Most of them are based on C or C++, because these are low level codes. These are what you have in the Linux project or the GNU. Then there's the frameworks folder. So this really, when we talk about the Android platform, most of the code is in this folder. Okay. If you want to have a look at what are the things I'm showing here, what you can do is you can either go to this site, okay, this android.googlesource.com, and you can search out the source that I am showing. Like there will be, those of you who have internet, you can search out like this frameworks, AV frameworks base, all the frameworks source that I'm showing from my laptop. You can see the exact same source available on the net. Either this, or you can also use a mirror. It's github.com/android. It's more cleanly presented on GitHub. So here also, say I'll search. There's a frameworks base. This is the main platform source. You can look around here. I will just show it on my own desktop. So the frameworks has a lot of files. Say AV is where you have all the audio and the video related code. There is DRM related code. So framework is the initial diagram that I showed. The framework is a layer between your libraries and your apps. So it needs to talk to the libraries via obviously some lower level languages like C, C++, and it needs to talk to your apps via some Java abstraction. So your framework, you will see most of the places it is divided into the Java source and the native source with a JNI mapping across it. So whatever the main function of the framework is, like it's translating whatever you're doing in Java into some lower level system calls. So, for example, there is your media server code here. As you can see, these are all C codes. So these are again important. Like these are APIs to your hardware. As if you want to go into like change the hardware side, if you want to build Android for a new device, you will have to often change the code here, because these are calling the direct functions in your hardware libraries. So your hardware libraries, say for example, you are making a new device which has a camera chip that has not been used on Linux before, Android before. So you will write your camera binary for it. So it can have functions which are not similar to what is present on the generic camera chips you have on previous Android devices. So you will have to come up here at the, you will have to, obviously you have to write the device driver for Linux first, and then you will have to change whatever calls it makes to the camera from the frameworks AV side, so that it like changing, say, the brightness or the exposure of your camera. So if your whatever the function calls are there on your binary, you will have to adjust it accordingly here. The base is something that has a lot of stuff here. So this file holds a list of all APIs that are available on Android. Okay. So during the Lollipop announcement, they said that they have added 5,000 new APIs. You noted that? So when they said 5,000 new APIs, they mean that the number of lines on this text file, I mean not the number of lines, but number of APIs on this file, that incremented by 5,000. So here, all your flags, all your function calls, they are all documented out here. The CMDs are the processes like whatever Android has added, which are low level stuff like, this is the screen cap is what, this is your file that is used to record your screen, which was added in KitKat recently. So inside frameworks base, again, I'll be talking about, say for example, the core side. This has all the frameworks based core Java. This has most of the classes that you extend when you are working on Android. Okay, you say for example you are extending your activity class. So the source of that actually resides up here, activity.java. So what exactly can you do here is some of an important thing I'd like to show. So here is a particular function you can see here. This was not present on and AOSP by default. Okay, so we have this community project called AOKP, which is just like CyanogenMod. So this is a particular line, and the update immersive mode, the function has been added. What it does is so you can see my phone. Yeah. By the way, everybody knows immersive mode is. They've heard of it. In KitKat, with immersive mode is an API that if you call it, your app becomes full screen, and like I will show what immersive mode is. This happens. Your navigation bar goes down. You can pull it up like this. In any app you go. So it becomes full screen, like you see, and you can pull down all of this. Okay, so this as an app developer is available to you as an API. So what we did was we changed it in the activity.java file, which every app is extending it. So when I have immersive mode on across the whole OS, so every app is extending the activity.java, which is part of my system. So all the apps are becoming in immersive mode. Okay, so this is an example of say when you want to change the user experience or the interface across all apps. Say you want to change the themes and all. So you have to go down to the base implementation which everybody is extending, change it globally, and for everybody it changes. So using that, when we talk about what we can do improvements on the UX side is, this is not actually, this is just experimenting with it. Okay. So when you say how do you change the experience, how you change the experience is, you create a list of apps that users can update, which will automatically become immersive. Okay. So we have that, and what you can do is you can add the apps that you want into your auto immersive list. So whenever those apps run, they will run on full screen, whether or not the app developer wanted it. So you give power to the user to decide when some of the apps should run in full screen or not. So suppose you want you as a user want to use Facebook full screen all the time. So you make Facebook as an auto immersive app. So every time Facebook opens, it's always full screen. Then let's go to so you have this folder called packages here. Okay, so this contains a lot of apps which are part of the default system. So for example, you have the key guard, which makes your lock screen. You have the system UI, which is the shell. You have documents UI, which is in KitKat. They have added a new file browser kind of interface. When you want to attach files, you have this nice looking file browser now. So these apps are there. So for example, everybody knows that these custom ROMs make these toggles, right? Much before Android had quick settings, you used to have toggles, for example. So how you do that is like in system UI, you can go and so you'll have your status bar. This is the code that is going to run your this code compiles into your status bar. So you can change this. You have a toggles folder. You make a toggles folder. What you do is this toggles folder, any of the files that are in the toggles folder, they are going to create toggles. So you add a lot of toggles. So you can toggle a lot of stuff in this. These are things that we have added. Like we have added a toggle to take a screenshot, a toggle to switch on off NFC, a toggle to switch between the various network modes, 2G, 3G, 4G, like that. So again, this can enhance the user experience. If you add too many toggles, it can be an irritation also. But so that again is something up to your purview how you're going to do it. So that was about the frameworks. Okay, let's. Since I'm talking about the UI, I will stick to that for a couple of more minutes and see. Finally, if you want to change the apps that are part of the OS, say for example, you want to change how the dialer works, for example. So they are all in the packages apps folder, and this part actually you can do. I mean, you will have to build the OS to be able to modify the ROM image, but as a developer, if you just want to change the phone app, you can just get one of these folders. You can download. Each one of them is a separate Git repository. You can download it. So I will tell you something interesting. So if you go and try to build this, it will fail to build. If you do it on something like Eclipse or on Studio, it won't build because the APIs, there is a concept of hidden APIs. If some of you have worked on some apps, like say before KitKat, if any of you wanted to work on an app that handles SMS in Android, so these APIs were not exposed directly. So you go into the OS code, you look at how Android's own SMS app works, and you call the related functions. But it's not all that easy to compile it because your SDK does not have all those APIs exposed. Okay, so for that I have written a oh, sorry. Yeah. So here's a script that I had written. What this does is it can create a SDK which has all the hidden APIs on it. So you can directly take this script, for example. So whatever APIs are needed, all of you Android developers, you know, there's an android.jar file inside the SDK. So every platform has a different android.jar inside which you get all the stubs of all the methods that are present in the system. So this script, it is available on this github.com/aokp/build folder, and inside tools custom SDK gen.sh. So What this script does is, for the first time, you will need to have the whole OS code. Inside the build folder, if you run this script, it will create an android.jar for you with all the hidden APIs in it. So you can create a new platform in your SDK folder. So like if you have your there are like Android 18, Android 19, Android 20, 21, these are all the SDKs. What you can do is you can create a new platform, say you're creating the hidden APIs of KitKat, create a new platform called Android 119, for example. Okay, copy the Android 19 folder, make it Android 119. Inside there will be a property file, change 19 to 119, and replace the android.jar file that you find it here with the android.jar that my script generates. So then you can simply build, you can modify the default OS apps on your favorite IDE, because that's comfortable, right? So you can do it on your IDE and it will compile also. Okay, and it will work on your system as such. So that's something that, I mean, these are the kind of little hacks you need to do to be able to comfortably work on, because I personally feel that, when I am working on Java, I prefer an IDE. So here, this is a list of, say, the default apps that you have. Some of the apps that I feel for a UX perspective that people like changing are like, for example, the dialer, the MMS app, and there are something that pertains to sometimes the hardware side also, because there's the NFC app and all that. So now let's get to the hardware side. Okay, this is about, I told how you can change the user experience. But for example, if you want to build a new platform, you want to build a new device. So first of all, there is the hardware folder, inside which you need there is a source code for all the different hardware that's present on your device, the device drivers, like we call them. So mostly for, say, a Qualcomm based device, you take the source code of the media side, the display, the audio, all of that from Code Aurora forums. So you can see there's this website called Code Aurora forums. So here there is a reference source code available for everything that's based on Qualcomm. Similarly, most other SoC or CPU manufacturers will have a particular website where they give out their reference codes. So you'll have to take that source code, and generally if you are building a new device, for example, so you can start off with AOSP, whatever code Aurora has been adding. For example, for Qualcomm, if you do for other device, you get your hardware code. This should be where you start from. That is one thing you have to do. Like I said, you have to obviously go into, you have to create a device / vendor / your device name folder. You will have to set up all your configurations. AOSP as such is not going to build your kernel along with the main build. Okay, so you can build the kernel separately and provide it as a pre-built, or you can use, suppose for example, CyanogenMod's build folder. So what that will do is it also builds the kernel along with the whole build. So kernel gets integrated right during the time. So then you put your kernel inside, say, kernel / vendor name / your whatever chip you're using. This folder is something that you can name whatever you want to. Again, some other things that I would like to mention here are, there is this folder called pre-builds. This contains all the cross compilers or binaries that you need to build. So when you're talking about hardware side of things, the C++ side, they have to be compiled. Like if you compile it on Linux, it is going to be compiled for this AMD 64 or x86 architecture, x86. So you have cross compilers which are going to compile C code for ARM so that you can run it on your device. Right from your kernel to your device drivers, all native code. So all those stuff are present. And whatever other tools that you need, some of the tools like all those who have worked on the Android app side would know about tools like AAPT, which packages your APKs, and Zipalign, and so these tools are built on the fly actually. So once all of you who will actually go home and try building it, you will find first time you build it takes a lot of time, because first you are going to build the tools that you used to build, and then you will actually build. And finally, there is this folder called vendor folder, which generally the reason we use it is there are a lot of parts of the system. Despite calling Android open source, there are certain things which are not open source. For example, your SoC manufacturer mostly will give some of things in binary format to you. They won't give the source for that. Okay, so there is a good example is Qualcomm makes a library called libqc opt. It's for Qualcomm based optimizations. You don't know what exists inside that, but if you run it, apparently your device runs smoother. So for all those things, there is a vendor folder. So here, as you can see, this is the structure of the system folder. So there are a lot of libraries here that directly they will just go into your phone's system folder directly, because these are libraries which you will just link to. So the vendor folder is mainly used for these purposes. For the binaries that you are not going to compile, you keep it in a vendor folder. They are directly copied to your kernel, the ROM image. Okay, so let's try building it. I think is this one visible? This is probably not visible at the back. I'll use this terminal itself. Okay. So when we want to build, this is given that the whole source code is present with you. After that, you source a configuration file which is present at build/env.sh. This sets up your environment for building the whole thing. Okay, you do this, then the people at Google have very funny names. They call launching. When you launch it, so you make your environment ready for one particular type of device. Okay, so this is like an embedded operating system. So this is not like your OS distros that you can run on any kind of hardware. This will be built specifically. If you build it for a particular phone, it will run on that phone, because there are a lot of constraints. You don't want to use a lot of RAM. You don't want to add a lot of drivers. You don't want to increase the size. So you just build with only those things that are needed for that phone and that phone alone, and not for other phones. So the launching configures it according to your device you want to build. So for example, I have my Xperia Z phone. Say I want to build for that. If you just click launch and press enter, you get a list of all the configurations that you have. So if you have got your make files all set up, then to add to the launch menu, you should you can do it at two places. Either wherever you have the device, you can add a file called vendor setup.sh either there, or you can have your own vendor. In the vendor folder you can have this. So this runs a lot of commands to add whatever configurations you have, like add launch combo, name of the device, like that. So this list comes up. So I want to do it for the Xperia Z, which is the Yuga. So I'm going to select number 66. So when I launch it, it is going to reset all the various configurations at various places to build for this particular device. Why this is needed is, as app developers, you will know that there is this LDPI, MDPI, HDPI thing. Okay, so you don't want to bundle all these resources unnecessarily for a phone which is, say, HDPI. You would not need the LDPI, MDPI resources if you have the HDPI resources. Exactly the same way for a LDPI phone, you don't need the larger resources. So this is one example. There are a lot of other things like this. So the launching will take care of all these things, that whatever particular configuration your device is of, it is going to set the build instructions in the respective way. After that, this little information box will come. It's going to tell you which version you're about to build, whatever CPU architecture you have, whatever host architecture you have. and it is going to show the out directory, which is where the source code is going to output into. Then there is the C cache directory. People who have worked with C++ know about C cache. How many of you don't know about C cache? So C cache is like for C or C++ code. It is going to keep a cache of, when you build it first time, it is going to keep a cache of your binaries. Next time when you build, it does a hash mapping, and if the source has not changed, it is not going to build it again. So creating a hash of a file is faster than compiling it, right? So you should use C cache always when you're building a project as large as this, because it's going to reduce your time significantly from the second build. Then the simple command is make. You can use a job variable to set number of threads that you have on your laptop or your build machine accordingly, and it is going to build as per that. Okay. So it's going to take a lot of time to build on my personal laptop. I can run a build in this amount of time on my SSH server instead. So that has I think 16 cores or something. So I will show you whatever the output is from a build folder there. Then this is something that you do make, and it creates the whole source code. Okay, but then going forward, you're not going to change everything all the time. So you're changing it component by component. So every module, like I said, is going to have and everything that has an android.mk file is a separate module as per the build instructions. Okay, so for example, I go to my any app. Let's select an app, packages apps, and say my camera app. So it will have an android.mk file, and which will have a local package name. Okay, this variable. So this defines that everything, if all the source inside this folder is going to build into a module called camera2. So what I can do is I can run make so okay, there are two ways of doing this. This is called component by component building. When you are going to change code, this will be needed a lot. There are two ways of doing it. You can either go to the folder, like here you can run a command called mmm. This command is available only after you have done the build/environment setup. You have sourced it. You will have a command called mmm, and you can do just mmm here, and it will build camera. But this will work only if all the dependencies are already satisfied. But if you do make from the top, then it is going to build whatever dependencies the camera package needs, and then it is going to build the camera app. Okay. This is one way to build depending on what source you want to build. There is another way to build depending on what target you want to build. So you can select something like make, and for example, the kernel is built at this path. The out is the variable for the out folder. Inside that, the kernel file is where your kernel comes out. So you can do make out/kernel, and then it will build just your kernel file for you. So this is by you are targeting it by what end product you want. So beyond this, see what you want to build or what you want to change is something that depends on what you want to do, but this pertains to a lot of the how about you want to change things. So I would like to know if any other questions you have regarding how you want to build things, because I'm not going to cover anything further on the how part. So I'd like to know if anything specific you want to know about how you want to build it. Any kind of questions you have. No questions about this part?
How exactly to figure out where to go and change files? For example, you know that this is where the camera is. Is there definite documentation for this, or you just hack around and figure out what is where?
Mostly I do hack around and figure out. Okay, so let's say for example you want to, it does come a bit over time when you keep seeing other people changing stuff you yourself changing stuff, you start learning where different code is. You have a basic idea like I give. See, something about the device drivers, it will be in the hardware folder. So you go inside hardware folder, do a find grep, and whatever thing you're searching for, you'll probably find out that way. So the base classes that you are extending for changing the APIs, that will always be inside frameworks base core, for example. Okay, so you get a rough idea like that. Then if you want to change a particular class, so a .java file, you will have to do something like, I want to find out, name a common file that is extended, any common Java class that is extended while developing an app. Yeah? Activity.java, okay. So I want to search activity.java. I will go to I'll just do find. So get all the files. We wanted this file, right? So activity.java, you find out like this. You got every other file that is ending with activity.java. So that's one way you find out what you want to change. Anything else? Yeah? Yeah? Kernel browsers, yeah. See, the kernel structure will be very much like the Linux kernel. Yeah? A kernel browser to like browse the source code of the Linux kernel. Yeah, but the problem is the Linux kernel source code for every device is quite different. So the Linux kernel browser works because there is a mainline tree of Linux kernel which is common to everybody, right?
Yeah.
So on the Android side, say 90% of the source is same as the Linux kernel. So your Linux kernel browser is giving documentation and the particular places where you get the source code. That's going to hold true for 90% of the source code of the Linux Android kernel too. The 10% that is different is implemented vastly differently for various different devices.
Okay.
So you got the idea, right?
Yeah.
So for example, I want to see browse through the code of Qualcomm devices. So maybe except the audio code, the video code, and the CPU code, everything else is mainline Linux.
Okay. Thank you.
So any other questions? Okay. So the next thing that comes is obviously contributing the source code back. I think that's a lot of people were asking me when I was outside. Right? We have changed it, so how do we contribute it back? So for that, I think I just give a sort of personal advice. A lot of people think that development pertains a lot to writing code. I feel that almost 50% of it is also getting acquainted with the tools that you need to do it. And one of them, the biggest ones, is your version control system. So if you want to contribute back to Android, to AOSP, or even if you want to contribute to somebody like Cyanogen, you will need to have a very good grasp over Git, over how repo is used, because say for example you change something, you push it up, and then it's in review, somebody says something, you change something, in between that something gets merged which changes the code exactly where you were working. So you need to have a very good command over conflict resolution and everything, because this is going to come up a lot. I remember like a friend of mine submitted a code to AOSP. It got merged more than a year later. So 2 Android versions came out between that. But it was a system related code, so that part had not changed a lot. It was a bug fix. So it lied on the Gerrit of the code review of Google for more than a year, and then it got merged. So obviously you need to be expert in rebasing and conflict merging and all of that. So I will give a quick overview on how that is done. So there is this, so this is the code review of AOSP. This is on the URL android-review.googlesource.com. So I will show something like, so I want to make a change. So I am This particular folder does not exist on AOSP, but what I'm doing, the commands, they are going to pertain to AOSP as well. So here repo comes to help a lot. So what you can do is say I am adding a file. So I created a file called test inside this folder, and this is, for example, this is my change, I want to contribute it. So I do what you do in generally Git, you add the file and then you do a commit of it. So I've added a test file and I've committed it. So at this point of time, what you can do is, I'm sorry, I had to take a step before that. You have to do repo start. So when you use the start command, it's going to start a development branch for you. Okay, in the same folder. So you do repo start. Say I'm going to. So you will have to start it with the same name of the branch into which you want to contribute. Okay, so I do repo start KitKat, and in which folder? In this folder. This is the. But so you will see, I am on the branch KitKat now. Okay, so I have to do the same. I think I have to do the same thing all over again. The test file has gone. So I've added this test file now. So this is the simple command that you use. You use repo upload. Okay. So you can run this command after you have committed a lot of changes on a lot of different sections of the code. So repo will search through the whole Android tree, and in whichever trees there are dangling commits, it is going to upload all of them to the respective review server. Okay. For if you are doing on AOSP, for all the folders, the review server will be the Android's review server. If you're working on some custom ROMs or something, sometimes what happens is different folders are taken from different organizations. So if you have worked across folders which are from different organizations, they will all upload it to their respective code review. How many of you know about Gerrit or Gerrit, Gerrit? Okay. So Gerrit is the code review system that Google started and a lot of people use now. They use it in a large scale way for Android and for the Chromium project for code reviewing source. So if you don't know about Gerrit, maybe some of you know about Review Board. So Gerrit works in a similar manner. So some more questions? Yeah, sure. So then you do repo upload. Okay, I think there's a issue is the internet here does not allow SSH access. SSH is not, report is blocked. Anyway, so if that command got executed, what happened was, this is Android's review, so a commit like this would have been formed. I was reviewing it to our project's Gerrit, which also looks very similar to that. You have a list of commits that have come. So it would have come up somewhere like this. Okay. So this, whoever has the authority will review it, verify it, and finally merge it. So this is the way you contribute to a project. Okay, so I would like to open up for 10 more minutes for some questions once again. So any questions regarding what I have said till now, or anything else? Any questions? So no questions? Fine. Okay, so what else do you want me to cover? That's a question from my side. Yeah. When your phone gets?
I think it's 12 ohms connection and
yeah.
12 ohms, right? Yeah, you do a serial connection and you give the power via the USB jack.
Yeah, I'm not getting
So when you do a mod flash,
you do mod flash, yeah.
Yeah, at times it gets bricked. Right?
At times it gets bricked, yeah.
Yeah. So those times you can actually power up the phone by inserting an USB jack of 6 ohms in serial connection. So it actually gets sold on eBay.
I know, it's called the fast boot cable.
Yeah, something like that. It's
So
actually
on that,
over the micro
USB has
USB.
got 5 pins inside it.
Exactly, yeah.
So you connect the fourth to the ground, it becomes a fast boot cable.
Exactly, that's right.
Yeah.
So is it something like official? Then why is it the option is something which you can avoid bricking itself?
So you can avoid bricking it itself. Okay, so that's a nice question. So how does the whole bricking thing come upon is, as a OEM, people want to secure the ecosystem because tomorrow if you run a custom ROM and you get a bad experience, you can go out and say that XYZ OEM makes bad phones. So because they don't want that to happen, that is the main motivation, I believe. They lock down. So locking down means the bootloader is going to verify the signature of each system partition before booting it. Okay. So if without a proper bootloader unlock, if you change the contents of the system partition, it won't boot. So that's one kind of a brick. But that's a soft brick because you can rewrite the system partition probably again via some exploits.
Okay.
And you can reboot your device. There can be hardware level bricks also. When we talk about hardware level, we mean if the bootloader gets corrupted. Because the bootloader gets corrupted, there are not a lot of ways to fix it yourself. Because anybody who has worked on the electronics platform would actually know that bootloader is not. There is no software way to write the bootloader. You'll have to use a JTAG or ICSP programmer, and you have to write the bootloader through that. So, I think that answers the question why the brick thing happens and how you can recover from it.
Yeah.
So the fast boot cable that you're saying is something that a lot of chipsets have this configuration that when you're connecting the USB, if the fourth pin is grounded, it boots into a hidden partition.
Okay.
So from there you can reflash your bootloader or your kernel, and then you can revive your device.
Okay. And one more question.
Yeah.
So say for example, I'm developing a mobile phone or modifying modifying an operating system.
Yeah.
Do you find any challenges in terms of privacy policies or regulations? So how far?
At the individual level or at an organization level? At an individual level, I don't think you will face a lot of problems.
Yeah, not at an individual level, more from the organizational level.
From organizational level. So if you want to, what exactly do you want to do? If you want to sell a custom firmware.
Say, assume I want to develop something like solidly secure with no backdoors and
a solid system without no backdoors.
Solid secure system.
Solid secure system. So whether the vendor who has actually made the phone will object to that or something like that?
Yeah, and also in terms of organizational policies, privacy policies. So how far does a developer or a
how you want to ask that how much the lawyers poker stick around the developers?
Yeah,
so they do poker stick around a lot with the developers, because if it does somehow hamper legitimate interest of the vendor, they will.
Okay.
As an individual developer, I feel the ecosystem is slowly becoming very conducive, because Sony used to help me. They still help me a lot because I used to develop on Sony phones, and I don't have any association with Sony as such. But they used to help me anytime I need any documentation, if I need devices to test something on, so they need to provide me. And really, what am I doing? I'm making custom firmware which deletes Sony's firmware and installs mine one, and they were still helpful towards it. So that's fine. But as a organization, if you want to do it, obviously they will have some objections to that. So maybe the proper way to do it is what Cyanogen Inc. is doing.
Okay.
Tie up with a hardware vendor and get it by default on some device.
Okay. Thank you, and the session was really interesting.
Thanks. So anything else, like I said, anything else you want me to cover other than what I have covered? If it's possible, I can.
How do you do this kernel debugging in this? Suppose you want to add the IP table support.
Yeah, yeah.
So how do you do the debug? Like in
How to do the kernel debugging is...
Linux, we have GDB and all, and we can connect and we can do that, right?
I think I have a device. I will just show you. Yeah, so I have a device connected. So I do ADB shell, and I can just do... So there you have your KMSG. Yeah.
So is there something similar to that here?
Oh, that I don't think would be available. Would be possible, like doing breakpoints on the kernel level code.
Yes.
Yeah, no, that won't be possible. I mean, as far as my experience is, it is not. But if you have a developer board and you have got UART connections to it, then it will be possible, because you need hardware interrupts for it. Right, like I think you have some experience with developer boards, so you will need hardware interrupts to actually debug the kernel. But via USB connection, you can't have hardware interrupts. I mean, this is I'm saying, yeah.
That's how we do it.
Yeah, you can do it via QEMU. You can do it.
Not the same, or it's something different than.
See, for QEMU, you need an abstraction of the hardware in the first place. Okay, so if you get an emulator for this thing, for ARM architecture, then only you are able to do that. So you will have some issues because you are going to run QEMU on a 64-bit machine and you want the kernel of a ARM device to be debugged. So there could be some issues. I'm not very familiar with this thing, because my experience has been mostly working on devices that are already built. So I have a developer board at my place, and you can actually do this kernel breakpoint, debugging the kernel via breakpoints if you have a UART connection to the chip itself, so that you can do interrupts via hardware, and that is possible. Anything else? Okay, so I guess that will wrap it up.